Hello, this is going to be the second tape on learning how to use the TI-83 graphing calculator. I'm going to be assuming that you already have some basic familiarity with the calculator. If not, you should first watch the part 1 tape. Okay, this is part 2. Now we have our calculator, and I have my calculator hooked to an overhead projector so that I'm going to be able to turn it on. Now to turn it on, of course, you hit the on button. And when I turn it on, if you have things on your screen, if you hit the clear button, you can clear it. We're ready to get started. Now, let's go down here and look at our chart showing the calculator. We have a window button. If we hit the window button, it's showing you the viewing window of the calculator. So if I press my window button, and we go, and next to window is zoom. I'm going to be hitting zoom in a few moments. Window and zoom. Okay, if we go up and look and see what our screen looks like, when we hit the window button, it looks like that. Now yours may not look like that. If you hit the zoom button, and you look, the two we're going to be using the most for viewing windows are 4 and 6. 4 is Z decimal and 6 is Z standard. Okay? If you hit 6, either you can take your cursor down to 6 and hit enter, or just you press in the number 6. Okay, well it's already graphing a function that I have on display. If I hit the y equals button, I had previously entered in y equals x squared. And it's graphing y equals x squared by hitting graph. It's graphing y equals x squared on the window. If I hit the window button again, it's graphing it from -10 to 10 on the x-axis and from -10 to 10 on the y-axis, in increments of 1. Okay, so this is our viewing window, and when I hit graph, it graphs that function y equals x squared in this window. Now, if I hit the zoom button again, and this time I press 4, just hit the number 4 to get Z decimal, it changes my viewing window. If you hit window, we're now using the viewing window where x is from -4.7 to 4.7 and y is from -3.1 to 3.1. In the first videotape, I explained why this viewing window is desirable. When you graph the function, if you hit the trace button, in other words, trace is right next to, we have window, we have zoom, we have trace. Trace is over there. If you hit the trace button, okay, it illuminates that it shows you the curve is y equals x squared, and the flashing point is at x equals 0, y equals 0. If you then move your cursor to the right, we have here 4 arrows, left, right, up, and down. If you move the cursor to the right or left, in conjunction with the trace button, it will generate various points on the curve. And while it's doing that, if you watch what's happening, moving the cursor to the right, while it generates it, it gives you the new coordinates of the point. Point 4, it was 0.4, 0.16, 0.5, 0.25, and so on. And we go to the 0.11, 1.1, 1.21, because the curve, of course, is y equals x squared. Now, if we were, let's go back to the origin, if we were using the other viewing window, in other words, if we hit zoom and 6, zoom standard, and we graph this, okay, we hit trace, we start at 0, 0, but instead of incrementing by 0.1, you're incrementing by this very strange number, about 0.213. And again 0.213, and so on as you go up the curve. So that's one of the advantages of the decimal window, and this is explained, of course, in the first videotape. Now, if I want to go back to my home screen, I will hit I want quit. So second, and then this mode button, second and quit. And that puts me back to my home screen. The home screen has the flashing cursor. Now, there are two other buttons I want to explain right now. We have a format button and a mode button. Okay, mode and format. If I hit mode, it shows you the settings on the calculator. Now, the default settings on the calculator are all of the ones on the far left. In other words, where the calculator, when it's originally purchased, is set up to be in radian measure, for example, instead of degree measure, which is fine for calculus. Down here, we have a choice between connected or dot mode on graphing. If I wanted, for example, to switch over to dot mode, and if I hit enter, okay, if I then quit this and went back to graphing y equals x squared, it would not connect the dots on the individual points. Okay, now that's not something I particularly want right now. So I'm going back to I'm going to quit what I was doing, go back to the mode button, and put it back where it was, which was on the connected mode. I hit enter there. Okay, so each of these options has an effect on how you do your calculations and how you graph functions. Okay, the other button I wanted to discuss with you, going back to quit, if I wanted the format button, second and then format, okay, it says we're working with rectangular coordinates, which is fine. The coordinates, okay, I want the coordinate axes on, well, coordinates on. I want it to indicate when I have to hit the trace button what the x coordinate and the y coordinate are. I don't want the grid on, because the grid gives you all the dots like if you had graph paper. I don't want that on. I'm going to leave that off right now. I want my axes on, but I'm sophisticated enough I don't need them labeled x and y axes. It's just going to get in my way. And when I hit the trace button, I want the expression, the function that I'm sketching to be illuminated. So it'll give me y equals x squared, and because the coordinates are on, it'll tell me what x equals and what y equals. And once again, the default setup is the far left in this button, in this format mode. Okay. Back to second quit. Okay. Now, my window right now is the standard window, and if I wanted to get the other one that I had mentioned before, I'd hit for the decimal window. Now, if I hit y equals, I can feed in a function that I might want to sketch. Okay, let me clear the function that's in there right now, and let me start my first example. Let's draw in y equals 1 minus x squared. So I'm punching in y equals 1 minus x squared. Okay, there are two minus signs, in a sense, on your calculator. I'm using 1, then the minus, and then the x button, and then I hit squared. This is for subtraction. This minus in parentheses is for negative numbers. Okay? Sometimes we use this, sometimes we use this. Now we're using 1 minus x squared. For negative numbers, we'll need this. Okay, now if I hit the graph key, of course it graphs y equals 1 minus x squared. And if I hit trace, it starts usually near the origin. X equal, here it gives me x equals 0, y equals 1. If I move my cursor to the right, it's generating points on the curve, telling me what the curve is, y equals 1 minus x squared, and what the x and the y coordinates are as you go through. And I can go either left or right. Okay. Now, there's another way of changing the viewing. There are a few ways of changing the viewing window. Right now we're using the decimal window. We could, of course, change to the standard. And you can, by hand, change and edit any of these x and y values that you might want to. And we did that on the first tape. Another thing, hitting second and quit, if we go back to graphing, another option is to make a box about an area that, which actually show them the viewing window that you want, and the calculator will adapt. So if I hit zoom, and it says the first option is Z box, I want to box in a new viewing window. So if I either hit 1 or just hit enter, because 1 is the first option. Okay, move your cursor to wherever you would like a corner of your box to be. So let's say I want my new viewing window, and that's a corner. That's going to be the upper right-hand corner of my new viewing window. Hit enter. Now move either left or right or up or down to indicate what my new viewing window should be. So let's say I want to show this part, and then move to the left. This is the new viewing window. Now hit enter. It redraws the graph in this new viewing window, which I got from ZBox. If you hit window, you will see it has changed. Okay? It has changed the viewing window for you automatically to correspond to what you showed it on the box. You can it's like drawing in your own viewing window, and sometimes this is very convenient. Okay, go back to graph. We now have this viewing window. Now, if you want to go back to the other one, you of course would hit zoom and back to, say, hit 4, and you go back to the one that you had before, and your window has been returned to what it was. But that is an option. If you want to blow up a particular portion of the curve, you can do that using the Z-box, drawing a box around the region that you want. Okay. Now, let's try the table. Let me show you a few more keys here. Over here, we have table set and table. Table set and table. This is going to produce an X, Y chart, similar to what you used to do when you used to just plot points for this particular function. If I hit, that's what table does. If I hit second and the window button, I'll get the table set option. Second to get table set. This is the way we generally would like to have this. In other words, we have ask under independent variable and auto under dependent variable. Okay? If you have it the other way, if you hit enter here and you then hit table, it will automatically give you values for X and the corresponding values for Y. And you can go, in other words, up or down in any direction. However, most of us want to be able to put in our own values. So we go back to second and table set. Second and table set. And I would prefer to have ask. In other words, you ask me what the independent variable should be. So ask for independent and automatic for the dependent. Now hit table, the second and the graph key to get the table. And now it will give me whatever points I feed it. For example, if I want to know if X is -3, what is Y? Now when I wanted -3, I used the minus sign on the bottom. Not minus here, but this one in parentheses to indicate the number -3. So I hit my -3 and I hit enter, and it tells me the corresponding Y value is, of course, the function is Y equals 1 minus X squared. So if you're substituting in -3, 1 minus 9, of course you should get -8. And you can plug in whatever values you want. If you want to put in -2 or minus 1.74, whatever, it's there available for you. Okay. If you want to clear this, go up to the top and start hitting DEL, the delete button, and it'll clear everything out for you. Okay, now let's eliminate that function there. Y equals 1 minus X squared. And I want to replace it right now by y equals sine x over x. And I'm interested in looking at a table. Now, in your calculus classes, you're going to be interested in what happens to sine x over x. What happens to this function as x gets close to 0? And you might try x values like 0.5, 0.1, 0.01, 0.001, etc. Want to know what the y value is going to look like in these cases. What happens to this function as x gets close to 0? Right now, we're just looking at positive values. So I'm going to enter in for y equals sine, and it automatically gives me the x parentheses on the 83, but not on the 82. In the 82, you have to put the parentheses. Put the x, close the parentheses, divided by x. So my function is y equals sine x over x. And I hit second and table. And if I would like to find the y values out here, I punch in 0.5, and it tells me what the y value is. And I hit 0.1, and it tells me what the y value is. 0.01, and it tells me the y value. 0.001, and it tells me. Now, what it's really giving you is only, though, 5 decimal places of accuracy there. If you really want to know what the full number is, in other words, is this number really 1, move your cursor over to that, and on the bottom it illuminates that, no, it's not really 1, it was 0.999999883, and so on. But to 5 decimal points, yes, to 5 decimal points it was 1 point and then 5 zeros. Okay. Similarly, if you go up 1, that was 0.999983, and then whatever you see there. So if you want to see more places illuminated, put the cursor on the y value. Okay? And in this manner, you can observe the behavior of functions, and we do a lot of this in calculus when we study limits. You observe the behavior of functions as x takes on certain values, as x approaches certain values. So the calculator can certainly get you this information. Okay. Now I'd like to use the calculator to practice sketching the graphs of some functions. So let's go back to y equals. I'm going to clear that out. And the first function that I want to enter in will be y equals the square root of 4 minus x squared. Now, before we had calculators and we taught this topic, we taught our students to square both sides, to recognize that x squared plus y squared equals 4 was the equation of a circle with center at the origin and radius 2. And then to say, but y equals the square root, which is really the positive square root only, its graph is only the top half of that circle, because it's the positive square root. Now, with this amazing calculator, this is all can be done for you automatically. Now, when I'm going to punch it in, I'm going to hit second and the x squared button to get the square root. And then I'm going to ask for the square root of 4 minus x squared. So let's go to y equals. I hit second, the square root, and then in the parentheses, left parentheses already there, 4 minus the x, and then the squared key, close parentheses. Now I'd like to graph that, and automatically I get the top half of that circle. Of course, the window that I'm using is the z decimal window right now. Now, the next example that I'd like to do is y equals the square root of 2 minus x. So I hit y equals. Now, I don't have to erase this. If I'm not going to use it again, I can erase it. But if I just want to take the emphasis off of it, I can put my cursor over the equal sign, hit enter, and that takes the heavy equal sign off. That means don't consider this my function now under consideration. I don't have to actually erase it. But now I can put in the square root of 2 minus x, close the parentheses, and if I ask it to graph it, it'll automatically graph this function. It knows which one to use. If I hit the trace button, it'll tell you that the function is y equals the square root of 2 minus x. Right now I happen to be at the point 0, comma, the square root of 2 over there. And I can trace in either direction. But it knows that y2 is the function that I was concerned with now. I don't have to clear something. If you're not using it right now and you may come back to it later, you have that option. Okay. Let's go back to y equals. By the way, this is, if you squared both sides here, you would have a parabola. And if y is 0, x would be 2. If x would be 0, y would be plus or minus the square root of 2. This would be the entire parabola. The positive square root was the top half only. What if we wanted y is the negative square root of 2 minus x? In other words, if you don't see anything in front of the square root, positive square root is assumed. If you want the negative square root, you're going to have to actually put it in. So let's see if we can do that. Let's go back to y equals. And I'd like to put in a negative sign here. Now, instead of just rewriting the whole function, over here I have a button called Insert. If I hit second and DEL, I'll get the insert key. I can insert the negative sign that I want. The negative sign, not the minus sign, the negative sign. So I'm going to hit second, the insert, and then the negative to get the negative square root. So second, insert, the negative sign, and now it should be fine. And if I graph this, I should get now only the bottom half of that parabola, because it's the negative square root. If I ask it to trace it, it'll tell me it's now sketching the graph of y equals negative square root of 2 minus x. Okay, the next function I want to sketch for you is y equals the absolute value of x minus 2. Go back to y equals. I'm going to delete these. I don't need them right now. Clear this one. Clear this back over here. Now, I need absolute value. Absolute value is not present on the calculator as it is. I'm not sure about the 82. It might be part of the 82, but it's not on the 83. So to get absolute value, I'm going to have to hit the math key, and then I'll show you how to get it from there. So first, push math. Then move your cursor 1 over to the NUM, from math to the NUM menu, and the first thing illuminated is ABS for absolute value. Now hit enter, and we have ABS. In other words, this is going to be entered as y1 is absolute value of x minus 2. So I enter in ABS, now x minus 2, close parentheses, and I hit graph, and it graphs y equals the absolute value of x minus 2. Now, suppose I want to graph y equals 8 minus 2x. If I hit y equals, and I clear that, I don't need that now, and I punch in 8 minus 2x, and I hit graph, I'm not getting a terrific picture of what's going on because my viewing window is not particularly good for this graph. Whereas we know, for example, if y is 0, x is 4. That's okay, but if x is 0, y is 8, and that's cut off. So now I'm going to hit zoom. And now I'm going back to Z6, to zoom standard, hit 6. And it changed now the viewing window from -10 to 10 for x, -10 to 10 for y. And I have a better picture of what's going on for this particular function. Now, I'd like to show you how one would go about graphing a split function on your calculator. Okay, let's say the function I'd like to sketch is the following. F of x is 4 minus x squared if x is less than or equal to 2, and x minus 2 if x is greater than 2. Okay, this is the function we want to sketch. As I said, before calculators, we would sketch y equals 4 minus x squared separately, y equals x minus 2 separately, come with our scissors, cut it at x equals 2, and paste down the left part of this curve and the right part of this curve. The calculator, however, can do this all for us if you enter it properly. Now, the proper way to enter a split function would be y1 equals, now, we have to say 4 minus x squared, parentheses, x less than or equal to 2 plus, now this would continue over, but I don't know if the camera would follow it, so I'm just going to continue it here, but it really should be over there. X minus 2, parentheses, x greater than 2. Okay, what the calculator is going to do here is when you feed it in a value, for example, if you feed it in x equals 3, it's going to say 4 minus 3 squared, okay, whatever that is, 3 less than or equal to 2. Now the answer to this, 3 less than or equal to 2, it's going to test it. If 3 is less than or equal to 2, if it's true, it'll say 1, and if it's false, it'll say 0. So 3, of course, is not less than or equal to 2, so it'll say 0 here, which means whatever this was, it's not going to use. Instead, it'll say 3 minus 2, the y value is 1, because 3 greater than 2 is correct, and it'll assign a value of 1. So these are tests, and the answer is either 0 or 1. If it's true, it's 0. If it's false, it's 1. So it'll automatically know which portion of the curve to use. So let me enter this into our function. Okay, I'll hit y equals, let me delete this, clear that rather, and I'm going to enter left parentheses, 4 minus x squared, right parentheses, left, x. Now I need less than or equal. The less than or equal to key is on test. Now just look over here. Above math is test. Second and then math will give me the test. So second and then math to get test. It gives me choices. Now what did I want? I wanted less than or equal. Less than or equal is option 6. So I hit the number 6 and puts in a less than or equal for me. Then the 2, then the right parentheses, then the plus, then left parentheses, x minus 2, right parentheses, left parentheses, x, and now I want greater than 2. Okay, greater than, once again, second and math to get test. And I want greater than, so that's option number 3. Hit that, get the greater than, put the 2 in the right parentheses. So I have 4 minus x squared when x is less than or equal to 2, and x minus 2 if x is greater than 2. Right now my window is the standard window, and I hit graph, and it gives me the parabola up to, including the point 2, 0, which is what I expect, and then it switches to the line. Automatically, it's doing it for you. Now I want to show you another example, which is similar to this one. Let's say we had g of x And I want to have a split function with 3 parts. Let's say we had 4 minus x squared if x is less than or equal to 2, x minus 2 if x is between 2 and 4, not including endpoints, and 6 minus x if x is greater than or equal to 4. Okay, this should be entered in the following way. y1 or y2, whatever you're using. 4 minus x squared, just like before, x less than or equal to 2, plus, now, x minus 2. You could enter 2 less than x less than 4, but the calculator would not understand it. Instead, make this 2 less than x, x less than 4. Don't try to do it in one. Even though you could force your calculator to write it, it won't understand it. Make it 2 less than x, or x greater than 2, and x less than 4, plus 6 minus x, x greater than or equal to 4. This is how it has to be entered in. So let me do that now. Y equals, let's see, can I save some of this? The 4 minus x squared if x is less than or equal to 2 is okay. Okay, now x minus 2, over here, I'm going to change this. I want 2 less than, so second in math for the test, 2 less than x, and then the right parentheses, and then left parentheses, x, second, oh, I skipped something. Let's see what we've got. 2 less than x, I want right parentheses here, then left parentheses, x, second, and test, I want less than. Again, less than is 5. 4, close parentheses, 2 less than x, and x less than 4, plus, left parentheses, 6 minus x, right parentheses, left parentheses, x, second, test, greater than or equal is option 4, and then the number 4, close parentheses. So 4 minus x squared if x is less than or equal to 2, and x minus 2 if x is between 2 and 4, and then 6 minus x if x is greater than or equal to 4. I hit graph, and I have the parabola, then the line, and then another line. It's what we expect. We part of the parabola, and then followed by one line and another line, which is actually makes a right angle because the slope here is 1 and the slope here is minus 1. And it gives it to you automatically. Okay. Now, the next thing I want to show you that you can do on the calculator is to solve an equation. The equation that I'm going to solve now is x cubed minus 2x squared minus x plus 1 equals 0. X cubed minus 2x squared minus x plus 1 equals 0. What I'm going to do is to enter for y1 x cubed minus 2x squared minus x plus 1, and I'm going to graph it. That's how I get started. So, clear. Okay, for y equals, let me clear out what I did there. Now, putting in x. To get x cubed, you can either go x to the third power or hit math and 3 to get the cube. Minus 2x, hit the squared key, minus x plus 1. And let's graph this. And it looks like that. Now, solving the equation is basically trying to find the points of intersection of y equals x cubed minus 2x squared minus x plus 1 and y equals 0, which is the x-axis. So basically, solving the equation is finding the x-intercepts of this curve. I want to find out where this curve crosses the x-axis. That's what I'm looking for. If I am solving simultaneously the equation of this curve and the equation of the x-axis, I'm going to find out where this curve crosses the x-axis. That's what the roots of this equation correspond to the x-intercepts for this graph. Now, I see most of the action seems to be occurring in the other window. So what I'm going to do is hit zoom and hit 4 to blow up the region that's more of interest to me. Now, it looks like there are 3 roots for this equation. Solving this equation, I should have 3 roots or 3 x-intercepts over there. Now, there are a variety of ways that one can use to find the roots of this equation, or correspondingly the x-intercepts. I'm going to show you 3 methods that we can use. There are others, but the most popular are the following 3 methods for solving equations. Method 1, which is probably the longest and the easiest to use, but it's the slowest, is the trace and zoom in method. Trace and zoom in. It has to be used repeatedly. Okay, we're going to be using the trace key and zoom. One of the options under the zoom menu is zoom in. Let me show you how it works. Okay, I hit trace, and I'm going to position myself by moving the cursor to the left somewhere near the x-intercept. Remember, the root of the equation corresponds to the x-intercept. Okay, so this is a rough approximation, but I want more accuracy. So I hit zoom. Now, zoom in is option 2. So I hit 2 and then enter. And it redraws this. Okay? Draws the picture around the root that I'm particularly interested in. If I hit trace, okay, the trace key still seems to be fairly close, and we'll move to the left. Try to get the trace as close as you can to the root. Hit zoom 2 and enter again. And if I hit trace, I'm still pretty close to where I want to be. Let's do it again. Zoom 2, enter. Now I've blown it up to the extent that the trace key is not so close to the root anymore. So I move a little to the left to get a better fix on it, and I hit again, zoom 2, enter. And I keep adjusting the trace. I hit trace, and I want to get a little closer to the root. And again, zoom 2, enter. It keeps blowing it up, and when I see that the flashing point is not where it should be, I move it. It seems close enough here. So I hit again, zoom 2, enter. And now it's a little off. I hit trace, and I move it a little up. Zoom 2, enter. And I hit trace, and I move it a little down to get to that area. Zoom 2, enter. And again, trace it, move it a little up. Of course, I'm getting better accuracy each time. If you look a little to the left, minus 0.810939, a little to the right, minus 0.80193. In other words, we see certainly it seems to be stable on the minus 0.8109. You can keep going depending on how you have to have an agreement between various iterations, or if you see a little to the left, a little to the right, it's locked in on, say, four decimal places, then you can be pretty sure that those four are correct. And you might want more accuracy. If you want more accuracy, you keep going with this procedure. You would hit zoom to enter until you see it stabilizing. Or what also happens is after a while, you're going to get an error because when you look, it's changing the window. Let's look what the window looks like right now. It's sketching the curve in a very small window. Eventually, you're going to get an error that the window is too narrow and it can't get you any increased accuracy. But certainly right now, whereas you're sketching in a window between minus 0.80195 and minus 0.8019119, you certainly know that, for example, minus 0.802 is correct without any question to 3 decimal places. Okay, so let's restore my window. Let's hit zoom. Let's go back to where we were with zoom 4, put the curve back. We now have an idea that that first, okay, it looks something like this. And we now know that this is approximately minus 0.802, 0. So the root is approximately minus 0.802. And in a similar fashion, it's tedious, you would go then move your trace key closer to this root, and you would again hit zoom to enter repeatedly until you get approximately what that root is. And it turns out you can practice this, and this turns out to be approximately 0.555. Comma 0. And finally, the last root, using the zoom to trace, zoom to enter repeatedly, you get 2.247 approximately. Okay, this is tedious, it works, but it's certainly not the most efficient method for finding the roots of an equation, the trace and zoom in. Okay, the next method I want to show you is to use the solve key. It's the solve function. Actually, if you have a TI-83, there is a solve button in the math menu, at the end of the math menu. For those of us with the TI-83, let's hit second quit. If I want solve, let's look what's going to happen over here. For the 83 people, if I want to get the solve function, I'm going to have to go to the catalog, which is like a dictionary of functions. I'm going to hit second and the 0, which is catalog. Okay, when I hit catalog, it's going to be at the beginning of the alphabet. So then I'm going to hit the key here that says LN because it has the letter S. It'll get me to the S part of that dictionary. So second, catalog, and then S. So let's do that. Second. Okay, second, catalog. That's the beginning of the alphabet, then the key that says S. And let's scroll down till we get to the function that says solve. Okay, now, I scroll down to S. Remember, I hit second, catalog. I got the dictionary of functions. I hit the S button. By the way, I do not have to hit the alpha key. I just hit the button that says LN. It automatically gets me to the S section of the dictionary of functions. And I scroll down to SOLVE, and I'm hitting enter. And if I hit enter, I have solve there, ready to go to work. Now, I want to tell it the function that I want it, it asks, what function do you want it to solve? want to find the roots of what equation? y1 was the function that I'm trying to solve. X is the variable, and in here I have to put a guess at the root. Okay, so now how do I get, there are two ways. To put in the function, I can actually punch in the function that we had for y equals, which was x cubed minus 2x squared minus x plus 1. You can actually punch that in and write it in, but it's not convenient. It would be much more convenient if you hit y, if you could put y1 in directly without doing that, and that's what we're going to do. Let's go back to second quit. Now if I want y in, I'm going to do this. I'm going to hit the key that says variables, V-A-R-S, variables. It's going to give me a choice of x or y variables. I'm going to go for y variables, and the first y variable is y1, and that's going to put it in there. Let's try that. I hit variables. I move my cursor over to the y variables. Under function, I hit enter, and I want the first of these, y1, and I hit enter, and it puts y1 right in there. Now I'm going to hit the comma. The comma is directly above the 7. The comma is above the 7, so comma. And I'm going to actually write down that the variable is x. Put in the variable x, then comma, and I need a guess. Now, let's go back to the graph. There are 3 roots for this equation. You have to point it in the right direction. Okay? So if I'm looking for this root over here, I have to give it a guess somewhere in that. It doesn't have to be right on the money, but let's say I feed it a guess of -1. I want something in that range. So I go second, quit, back over here. I'm putting in -1, close the parentheses. So solve, find the root of that equation, y1 equals 0. Variable is x, the guess is -1. Hit enter, and it immediately gives you, with that accuracy, the answer that we were struggling over with the trace and zoom in. So minus 0.8019, it has many places you might want there. Now, if you hit graph, that's fine for that one, but I'm interested in the other. So I move my trace and I say, what's the next root I'm looking for? Somewhere in this vicinity. Okay, so let's say we're feeding it. We could do this just by, you don't even need the cursor. You can just say about 1 is my guess. So I go second, I go quit. Now, I could rewrite this, but I don't have to. Down over here, where it says enter, the yellow, the second and enter, gives me entry, gives me the last thing I entered into the calculator. Second and enter. So I'm going to do that. Second and enter. And that feeds me the last thing that I fed into the calculator. Now I'm going to go back and I'm going to delete the minus sign there. So now I'm going to say, okay, now my guess is 1. I've edited that, hit enter. It immediately gives me the 0.555, which was the middle root. And then the last root, if we hit the graph, the last root seems to be somewhere in the vicinity of 2. So let's try that. I'll say second quit. Second, enter, and now let's change the 1 to a 2 as my guess, hit enter, and there you have the 2.247 approximately. Now you've got to be careful because the problem is if there are 2 roots that are fairly close to each other, you don't know what the guess is going to give you. So if I hit, for example, second and solve, and if I fed in 1.5, it would give me the middle root. If, however, I hit second and enter, and I fed in, instead of 1.5, 1.6, it would automatically jump to the other root. Okay? In class, you'll learn something about how the solve key works, but you can't assume you're necessarily going to get the root that you want. That's one of the problems. It's certainly an efficient method, but that's a slight drawback. Which brings us to the third method that I'm going to show you for finding the roots of an equation. Third method is in the calc key. The calc key is over here, second and calculate. And now, And it's option, if you hit second and calc, it's option 2, which is to find a zero of a function, or a root of a function, or to set the equation equal to 0 is what it's actually doing. It can only work on setting an equation equal to 0. So you have to bear that in mind. So let's see what we can do here. Let's hit option 2. I want to find a root of this. Now, let's move my cursor. It's going to ask you for a left bound. It's going to ask you to bound your root on the left side and on the right. So I'm looking here. I say, OK, that's clearly to the left of the root that I'm looking for. So I hit enter. Then it asks me for a right bound. So I move my cursor. So I'm clearly to the right of the root, and I hit enter. Then it's going to ask me for a guess. So let me back it up a little. That looks like a good guess. And I hit enter, and it produces automatically the 0, or the root. And then we have, once again, the minus 0.802. But here you can be sure it's going to give you the root you want because you've bounded it in on the left and on the right. Let's try that again. Let's hit second and calc, and 2 for 0. But now let's move myself over here. I'm looking for a left bound. Let's say this is my left bound. I hit enter. Now to the right, to know that I'm past the root, I'll hit enter. And for my guess, let me back it up someplace in the middle. I hit enter, and then it says the root is 0.555 approximately. And repeating this again, second and calc, 2 for 0. But let's move it over to the root here. I want a left bound, let's say over here. That's clearly to the left of the root. I want a right bound, and then a guess. And it produces the 2.2, oh, I hit something, sorry about that. Shouldn't have done that. Let's go back, second, calc, 2. It had left bound, right bound, guess, enter, and it gave you the 2.247. Okay, so we've seen 3 ways of finding the roots of an equation. I think the calc button with the 0 key is probably the most efficient. Let's try one more example quickly. And let's say we want to solve the following equation. Solve the equation sine x minus 3x equals 4. As I mentioned earlier, the method is dependent on the function being set equal to 0, finding the roots of an equation. So what we have to do is to rewrite this as sine x minus 3x minus 4 equals 0. That's the equation. So it's the 0, when you hit the 0 key, it's finding the 0 of an equation, or it's setting it equal to 0. So you have to enter it in as y1 equals sine x minus 3x minus 4. And then when you hit 0, it'll set it equal to 0. Okay, so even though originally it was given like this, you have to bring everything on one side equal to 0. This is what your calculator goes about solving. So let's try that. Let's hit y equals. Let's clear what we have there and enter in sine of x minus 3x minus 4. Hit graph. And in class you will learn how come this function has only one root, and in fact this function is always a decreasing function. But clearly the root that we're looking for is somewhere in that vicinity. Let's hit trace. Let's move to that area. The root is somewhere over here. Okay, so let's hit second and calc and 2 for 0. Now for a left bound, we can use this. For a right bound, we move a little to the right of the root, we hit that, enter. And a guess, let's back it up a little, somewhere like that, and I hit enter, and it produces the root minus 0.1665 approximately. And of course, you can use the other methods as well, the trace and zoom in, it's certainly slower, or the solve if you want to, and they will work as well, but I think the 0 is the nicest way of going about it. Okay, that'll bring us to the end of this tape. I hope you enjoyed playing with your calculator, and there is just so much you can learn how to do. Have fun with it. Bye-bye now.